Okay, thank you very much. Good morning to you in Spain. I didn't really expect to see familiar people in this workshop, but I think all over Europe this topic is quite pressing. So this is a real pleasure for me to speak to you within this workshop, as IT Innova is one part of the project that we are presenting here. Just quickly, who we are here in Virtual Vehicle. We are a subsidiary of the Technical University Graz, together with the three main industry players here in Graz, which is Magna Steyr, AVL, and Siemens. So we share about each 50% of Virtual Vehicle, and we have about 205 to 210 employees with a 22 million turnover. And our main target is to developing methods for mainly the automotive industry, but also for rail and aerospace. And we are quite active in the European research community. Just a quick overview. We have a lot of projects running there. And the Facts4Workers, which I'll present here, is one of it. Okay, that's enough on the commercials, and I would like to go quickly to the Industry 4.0 on our interpretation. I'm quite sure that you have heard a lot on standard Industry 4.0 interpretations, and I would like to just briefly cover this one because our interpretation, I think, is specific and has led us to this project, I think. And well, let's see. I think you have probably seen this chart before on the four industrial revolutions, and especially if you look at the fourth industrial revolutions, there is you could read out of this that you probably this industrial revolution is purely on the technical side, the interconnection between robots and mobile devices, and everything is connected and whatsoever. And I'm absolutely not happy with this chart in this respect, because people are nowhere in this chart visible, and I think that is a main failure or a main problem in this analysis there. We have done a little bit of different approach here. And when we look back to the three industrial revolutions we have to date, you can draw them onto two separate scales. One is the economy of scope on the vertical side, and the economy of scale on the horizontal side. And if you start on the handcraft work, where the worker or the handcraftsman had a real customer focus and was very focused on what to produce directly, so what is needed. The other industrial revolutions didn't come close to this one. The first one did just only do what you did more quick. The second one did not anyway focus anymore on this economy of scope anymore. I think everybody knows that speech from Mr. Ford, that you can order all the colors of the vehicles as if they are just only black. And the third industrial revolution with the automation didn't focus too much on this one more, but only increase the economy of scale with a little bit more variety of products. And we think with the fourth industrial revolution, with cyber-physical systems and so on, this target comes again into play, this economy of scope, that you focus exactly what the customer and what the real scope of the product needs to be. And if you look back on the enablers of these industrial revolution, the first one, the mechanization, second one, division of work, third one, electronics and IT. So we think the enabler for the fourth industrial revolution is not so much only the connectivity between machines, but more the collaboration of man and machine. There is still the collaboration of machine and machine, which is the technical view on the Industrial Revolution number 4, but especially on the collaboration between man and machine, and for sure also man and man within this environment also. And I think we do not also have to forget that industrial revolutions always reflected the social status of these times. And if we neglect this one, I think we do a major mistake. We just had last week here Professor Walster, and he is strongly supporting this view. And he says that the smart factory in the future will not be deserted, will have still the workers, because they are really, with their sound mind, the best choice in the factory of the people, because they are superior to any technical expert software when it comes to special situations. And coming back to the last slide, we will focus more and more on these special situations, because mass production is what we brought us forward. But we are going to focus more and more on specific production, exactly what the customer needs. So if you think on lot size 1, lot size 1 production is quite easy, but you have to produce it also in competitive price options, and cannot fall back behind the mass production components there. And why is that now relevant? You know, probably the Gartner hype cycle, and I'd like quickly to draw that all technology runs basically through such a curve. It starts with a technology trigger, and there is a high peak of the inflated expectations to this technology. It comes down again through a throw of disillusionment, where you see, okay, this technology probably is not exactly helping you further. But at the end, you have some enlightenment, and then you learn how to best apply it. And if you focus on the technologies in the Industry 4.0 areas, so I've just picked some of them out of this review, which smart robots, Internet of Things being definitely on the peak at the moment, big data and augmented reality, so all these technologies which are relevant at the moment, machine-to-machine communication, cloud computing, activity streams. You see that the key technologies are obviously at the edge of being ready to be applied within the industry, because they approach the plateau of productivity and the slope of enlightenment within the next years. So at the moment, this is the time now to start using these technologies and implementing these technologies, and that's why also these projects evolve now. Coming to the challenges, both in the industry and in the project, you're probably familiar with this automation pyramid. And coming back to the topic, what changes on this one if you produce lot size 1? We think that the lower levels will definitely stay the same. So sensors and production machinery and so on will have the same concept as before. But if you look at lot size 1, all the control levels, like the supervision levels on the machine and the management level with the manufacturing execution system, and the enterprise level with all the KPIs what are present, they lose their meaning in this respect, we think. So when we think of the work and the people of the most flexible link what we have within in the smart factory, that we think that these systems more and more get cloudy and we have not so much a clear view on this one. So if you think it doesn't make sense to write a work instruction if you just produce one piece once at a time. So it is increasingly on moving these tasks directly to the worker and give him the responsibility to do this. And at the top of the slide I've written down concept of subsidiarity. Some of you may be familiar with the politics with this concept. It means that all decisions should be done at the lowest possible level. And if you try to move these decisions, whether to produce now a component on this machine or not, or wait for another one, if you can move this decision to the worker or to the lowest possible level, then you get much more flexible. And in the politics, you see basically this concept. The more complex it gets, the lower the decisions should be transferred. And only if this level cannot do this decision anymore, it should be escalated to the higher level. So the challenge is in the project about this. We have a lot of requirements for this worker if he has to do these decisions directly. I've put ones in at the top, which is ensure safety, which is basically one in the smart factory, which is for the worker a basic requirement. And all these technologies are purely designed for the use in completely different areas, what we've seen before, like video streaming or like big data analysis or whatever. So they don't have the problem that there is a people behind a potential dangerous area. So the worker needs to have tools in a completely different environment, and the problems are having hardware which is not designed for this one, having dangers in a factory on any kinds. By far, not everybody in the factory is speaking English. You can easily find shop floors where you speak 20 or 30 or more languages easily. So in my previous company, Magna Steyr, we had 44 different languages at the shop floor. You have different factory environments, and the key question is now how to apply all these technologies with these boundary conditions to support these requirements here. And this is what it's all about in our project. And one more slide in this area is also the EU Commission saw during the crisis between 2007 and 2012, and I've quickly drawn the figures here. We have lost a lot of jobs in the industry, and the role was shrinking, and we need to come back with the attractiveness of Europe as a production location. Where to invest, and we clearly think that Industry 4.0 applications and as these projects what we have are the main targets. So coming from this background, what do we develop in the project? So we want to increase basically the problem solving and innovation skills of the workers, making them or empower them to do these decisions directly where they are necessary in the shop floor, but providing them with the knowledge which is necessary for it. This will go hand in hand, we think, with a cognitive job satisfaction of the workers. So, although the total man count in these industries will decline, we still need the people go into the manufacturing areas and see these jobs as attractive. If this will not be the case anymore, we will not get the best people there to go and work in the shop floors, and we're losing more jobs there. For sure, we need to increase the worker productivity, but not on a direct basis. So we do not want to directly increase this productivity by working faster, but by increasing these problem in innovation skills, so that the total productivity will increase. And at the end, we will have pilots which are in the technology readiness level 5 to 7, which means they are active in the partners, they are working and can be rolled out to other areas and other factories, copying these, and should be included in the actual production. Some hard facts on the project itself. The project is within the call Horizon 2020 Factory of the Future 4, with the title Developing Smart Factories Which Are Attractive to Workers. And there's also already the focus. You really need to have attractive workplaces also in the factories, not only increase the productivity there. We have a total of more than 1,000 person months, so the project itself is quite big. Also in this respect, so one of the biggest projects in Industry 4.0, also in the European context. So the partners, I think that's a key point. We have 4 large industry partners, which are ThyssenKrupp and Schaeffler, and also Hydria, which is a very large company, mainly in Germany and Slovenia. So these companies cover the most advanced technologies already. But on the other hand, we have two small and medium enterprises, like Thermo Olympic, and I think Jorge is also there in your workshop, and he will present one part of the project afterwards. This covers the variety of the workplaces here, not only in automotive, but also in other areas, and with completely different requirements. We have 5 research centers and 4 universities, which are doing mainly the development work and the implementations then. Okay, so what we did there is the industrial challenges. We have identified what is really the key to solve these topics. So we have 4 use cases which we want to do. The first one is a personalized augmented operator, which is fairly standard operation within all these projects. And the key point there is not to make an operator which is a human robot, and we everything tell him exactly what to do, but really empower the worker that he can do his job better than before. Second one is a worker-centric knowledge sharing, and I think this is one Jorge will also cover later, so I'll be brief on this one. Self-learning workplaces. This is the feedback of the workplaces to get back to the worker and giving better decisions. And exactly the last point, in situ mobile learning. So directly in the workplace learn what is the best way now to do next, and learn how the workplace self should be handled. The approach there behind is, so we have these 4 use cases covered over the industrial partners, and we have off-the-shelf technologies saying, okay, we have augmented reality tools, we have some intelligent dashboard services, and we have infrastructures and the data and everything to it. And the approach to this project is that we do not directly develop the technologies itself. So if you have back a look at the Gartner Hype Cycle, which I've presented, this is anyway evolving. So what we need to do in this project is applying this one to the shop floor requirements. So it doesn't make sense for us to develop augmented reality tools further because they're quite straightforward, we think. But the question is how to use them in a shop floor environment. And then the next point is combining these building blocks as it is useful for these use cases. And at the end, focus on the workers. And the traditional approach is you have all the lots of data and all the systems what you have already installed in the factories. So basically, you get some machine data, combining them and transferring them through the factory, and probably you condense them to a KPI or whatever, and then displaying it to the worker. But the project, what we want to achieve is, and the target we want to achieve is, turn this approach around. So coming directly from the worker, check what he really needs in this situation and turn this around and saying, okay, which data is necessary? How do we, how the worker himself can make use of this one, and if something is missing, we need to provide this one. And if he can't read it, how to get these to him that he can make really use in this situation for him. So at the end, why care about it? This is just Pericles. The Industry 4.0 revolution is a predicted one. So at this time, some people say, okay, it is not really a revolution, or it will happen within the next years. But we think we need to have this future not predicting, but we need to be prepared for it. So the question is, we need to start these projects really now. And finish them within the next 4 years. And another speech of Professor Kagermann, who is one of the founders of Acatec and board members of Acatec, so that he supports this one as well, saying, okay, the workers in the future will receive much less rigidly prescribed operating procedures. Because it is not so much clear anymore how this will look like. It doesn't really make sense to do this for very, very small lot sizes. And at the end, the girl in this sketch is saying, okay, if we go on like this, before she will be dead within 6 months, and the guy from the human resource said, okay, that's a relief. And explaining her, okay, with these new technologies, you can be replaced within 3 months, and she should teach her replacement also within this time frame. So this is the counterpart and the challenge, not to tap into this trap and really empower the worker to get the best out of it. Otherwise, these jobs will not be attractive anymore. So thank you very much. If you want to learn more on the project and as the project evolves, please look by at the Facts4Workers homepage. We regularly update this one, and you also can learn more on the key solutions, which will contribute here, or mailing us, and you can contact me directly also on this page. Thank you very much for this one, and I'm open for questions now.
Thank you, Martin, for joining us. Maybe we have some time to make some questions to Martin or about the project.
So if no one is asking you anything, so I have one for you, Martin. Hans was telling us before you that this is a matter of survival for companies. And I don't know whether the industrial partners of the project are really aware of how this new concept is about their future, or they just want to play with some tools and so on, but they are not really aware of how they are playing with their future with this new concept.
It's different. Some of the bigger companies probably are not, but the smaller companies, especially in our project, are quite well, I think. For example, we have one partner, a smaller partner, which is completely shifting these responsibilities to the worker at the lowest level. We have so he doesn't plan the production directly of his tools anymore. He has only a rough time planning for the production, and all the smaller areas and smaller amounts of components will be planned directly by the workers, by interacting with each other, and this puts them into a position where they are extremely flexible and extremely successful in providing tools for the industry in a very, very short time frame. So they have changed probably their business model on this basis. And you're probably right. If the business model itself doesn't change, some of the industry partner probably will not understand in time that this is really relevant for them. Yeah, if that answers your question.
Yes, sure. Thank you, Martin.
So, Martin, there's no more questions. So, thank you again for joining us, and see you there in the next meeting.
Thank you very much. Bye-bye to Spain.
Bye, Martin.
Bye, Martin.